Hello and welcome to SLU, the Community Observatory. I'm Paul Cox and I look after SLU's robotic telescopes, and they're the telescopes that our worldwide community of members control every night. Now, our primary observatory you're seeing here is at the world-class observatory site in the Canary Islands, which is off the west coast of Africa. It's home to some of the biggest and best telescopes in the world. But shortly, SLU are going to be reopening their Chile observatory, which means that SLU members will suddenly get to control the telescopes in the southern hemisphere as well. Anyway, you are joining us tonight for two of the biggest and best live shows we could do. First of all, we've got Mars. Mars is closest to Earth tonight than it has been for 6 years. And then, in a few hours' time, we are going to have live coverage of the total lunar eclipse. Now, I know that a lot of people in the USA and South America, where you can actually see this in your own backyards, I know there's a lot of cloud over there. So we will be providing you with live images so you can watch it all the way from beginning to end. Now, not only have we got those two events lined up, but we also have a fantastic promotion tonight. Join SLU to control those robotic telescopes alongside all of the other members, and you will receive a fabulous pair of free binoculars. They're worth $90. They are a really, really nice set. These are not cheap binoculars. They are fantastic. I have actually got my hands on a pair now. It's a limited offer today. We make no apology for running a promotion or telling you about SLU during our live shows, because it is what keeps us going. So please go along to the SLU.com homepage, click the membership button for details, and we'll tell you more actually about how to use a pair of binoculars a little bit later on in the show. Now, we've got our first live image of Mars. This one's a bit fuzzy in comparison to some of the ones we've been seeing earlier tonight, but we can just about start making out some of the features on Mars, and we'll talk about that in the second part of our show. The first part is we've got Rob Manning. Mr. Robert Manning, he is the MSL Chief Engineer, or former MSL, that's the Mars Science Laboratory Chief Engineer, and is now heading up an amazing project that he's going to talk to us about. But he's also going to give us a fantastic update about Curiosity. Sorry, which ones? No, we got Opportunity and Spirit. Sorry, I got a bit confused there. The two rovers on Mars. Anyway, Rob is going to give us an update on that. Then later on in the show, we are going to be joined by SLU astronomer Bob Berman, and he's going to explain why tonight is so special and why this is the first time in 6 years that Earth and Mars have been this close. He'll also explain why Mars is closest tonight, even though the planet's opposition was last week. Some people are a bit confused by that, so we're going to clear that up. And then in 3.5 hours' time, we are going to have the second of our big live events tonight, the total lunar eclipse. It is going to be an awesome show. We will be broadcasting live image streams of the eclipse so anyone can enjoy this gradual darkening of the moon, and hopefully we'll see the moon turn red or orange as it's plunged into Earth's shadow. Now, if you're lucky enough to live in North or South America and you have clear skies, be sure to listen to our commentary as you watch the eclipse from your own backyard. But for those of us, I'm talking to you from England, for those of us under the clouds or located where the eclipse isn't visible, we'll have those live images throughout the eclipse. So make sure you come back later for the live eclipse show too. Now, if you're watching in your own backyard, make sure that you join us in our little pre-show. So we're going to start a little bit earlier for the lunar eclipse, and we're going to tell you exactly how to watch it in your own backyard. But before our live eclipse coverage starting in a few hours' time, let's get back to Mars. our neighbouring planet that has captured the imaginations of kids like me, novelists, filmmakers, and scientists alike, and to help bring us up to speed on the current Mars exploration missions and what's planned in the future as well. I am delighted to welcome Rob Manning from NASA's Jet Propulsion Laboratory back to SLU. Good evening, Rob. Many thanks for popping back to update us on your exciting work on the Red Planet.
Good evening, Paul. Thank you so much for inviting me. It's a great pleasure to talk to you again.
Well, we were talking with a group of SLU members the other night amongst all of us, and we were saying, what was it that first inspired you to kind of get interested in astronomy and space? And one of them said, ask your guests on Monday night. Ask your guests. So, Rob, what inspired you to get interested in space and astronomy?
Well, great question because I was definitely inspired by the space race.
Oh, me too.
I was the perfect age to witness the dawn of the whole thing. In the early 1960s, Alan Shepard and the other astronauts, Gus Grissom, the whole a whole slew of the astronauts
Yeah,
suddenly filled my vocabulary, my brain, and I was watching first the Mercury missions and the Gemini, and then the Apollo.
I
And
know.
as a kid, you just followed it like it was a daytime drama. Every moment you could get your hands on a piece of paper or a magazine that explained something, because we didn't have the internet, of course, and
No,
so I was far from TV, so I had to get all of my information from newspapers and magazines, and so I scoured the paper to find out what was going on, and it was just such an exciting time. But gradually, we were able to watch black and white television shots of amazing things, such as Neil Armstrong's first steps on the moon. I will never forget that, July
I remember
1969.
Rob being woken up by my mother, brought downstairs to watch the black and white TV, to watch that very instant. And it was probably one of the things that, you know, put me on a path of technology and science for the rest of my life. So, this inspiration, isn't it amazing that all of us who are interested in this stuff, all of our viewers out there, have probably been inspired by something similar, a single event. And probably, a lot of that inspiration, a lot of our viewers out there have been inspired by some of the work that you've been involved with, because you've been working at the Jet Propulsion Laboratory, I think, since 1980. And I read that, I mean, I'm so jealous of your engineering career. It's absolutely amazing, the projects that you've been involved with. But I read recently that you quickly got hooked up on this tricky problem known as EDL, entry, descent, and landing. Now, what's the EDL problem, and why is it such a challenging engineering problem in relationship to Mars, which is what we're looking at tonight?
Wow, that's another great question. Yeah, it's funny. Mars is between the Moon and the Earth in size. So you think, well, it can't be as hard as Earth or the Moon. But what it is, it's a strange thing. When you land on the Moon, you don't have to worry about the atmosphere. And when you land on Earth, how do you land on Earth? Well, you have a heat shield, parachutes, and or your space shuttle has wings. But Mars is this really funny place. There's not enough. There's too much atmosphere to land like we do on the moon by firing rockets backwards and
Yeah,
simply keeping your rockets going until you land. And there's too much atmosphere to land like we do on the moon. And there's really not enough atmosphere to really land like you
with a
do on
parachute.
Earth.
Right.
Now you can try, but you're
Yeah.
not going to get. It's not going to get you down fast enough. Slow you down
Okay.
fast enough. And
Okay.
so we've had to do this Rube Goldberg set of stuff to get our vehicles to slow down before we hit the surface of
So,
Mars at a really high speed.
when did you first get involved in this engineering problem then of how to slow down a spacecraft before it lands on Mars? What projects were you involved with at the beginning?
Well, my first Mars mission turned out to be Mars Pathfinder in the early 1990s. I had been working in orbital missions like Cassini, Galileo, a bit of Voyager, and Magellan, and other space missions to the outer planets. But this was the first. It was a low cost mission, a faster, better, cheaper mission to land a little rover. rover that can at least sit in your lap, a Sojourner rover the size of a microwave oven,
Oh,
and
we've
landed.
got it here. We've got a picture of it here, Rob, and it's this tiny little rover which is on the far left. Is that right?
That's exactly right. Yeah, this is a scale of different rovers that we've built. Now, the first one, of course, was Sojourner, and we
Yeah.
landed it on July 4th, 1997. And we got it off the vehicle, and we were able to drive it across the surface. In fact, if you queue up it's another shot here. You can really get a good sense of the three rovers that have made it to Mars.
Ah, yeah.
The little one in the front is a little Sojourner. Um, and that was our first attempt at learning how to drive a rover on Mars. Now, you might say, well, what's with Mars? And you could drive a rover remotely almost anywhere on this planet. But there's something very special about Mars. It turns out because it takes such a long time for the radio signal to get to Mars, and there's other things in the way, like the Mars rotates, we can't talk to it all the
Yeah.
time. So we really have to create these vehicles to be autonomous, and we have to give them not we don't joystick them. We, in fact, give them instructions of what we want to do in the future. We give them a list of things to do. And the rovers have to do it themselves. They have to watch out for rocks. They have to watch out for holes. They can't drive off cliffs. And so these little rovers had to learn how to be autonomous. So we practiced that idea with this little rover Sojourner back in 1997. A few years later, we were able to, a friend of mine and I proposed that we modify Pathfinder and the lander itself and throw off the little rover and instead convert the lander into a rover. And those became the Spirit and Opportunity rovers that launched in late May, early June 2003 and landed on Mars in early 2004.
So let's
Now,
just take a look, Rob, at this image that we've got, where you've got this tiny little Sojourner rover, and presumably, the mass of that, it wasn't quite as difficult to get that down onto Mars's surface in one piece. But then you see this monster next to it, which
oh yeah,
is that Opportunity? Which
the
the
one
one on the
behind
right,
it,
the larger one on the right,
the large one on the right is Curiosity rover.
Curiosity.
The one on the left is one of two rovers, Spirit and Opportunity.
Yeah,
So there are now four rovers on Mars, and yes, I know where you're going. This is, if you thought landing a little Sojourner on Mars was
exactly.
challenge, just
Look at this thing next
what would
to
it
it with
take to land this little Sojourner
yeah,
weighs 11 kilograms. That big one in the back weighs 900 kilograms, and
wow.
so that's a huge amount of stuff that has to get to the Mars. And the problem with Mars with so little atmosphere, you have
Mm.
to pull all these tricks out of your pocket. You have to
So what are they? Tell us what these
so
tricks are then to
so
slow this thing down.
so it turns out that Mars atmosphere and Earth atmosphere are very similar. If you could find a mountain that's 120,000 feet, some 30 kilometers up, and if you could find a mountain that high and land on it, that would be what it would be like to land on Mars.
Okay.
So you can apply the same tricks for entry. You could use a heat shield, and I see you have a picture right there, ready to go. If you queue up the next picture, there it is. There's a heat shield. You can use a heat shield that protects the vehicle as it enters, but more importantly, that heat shield can slow you down. It can
Yep.
take away 99% of your kinetic energy. It's amazing how much
Wow.
that thin atmosphere can slow you down if you're going fast enough. And our
Yep.
vehicles are hitting the top of the atmosphere of Mars at 5.7 kilometers per second, 12,000 miles an hour, very, very fast. And it slows down in about a matter of 2 minutes. It's 2 or 3 minutes. It slows down to about 1,000 miles an hour.
And is that
Um,
what's called terminal velocity?
you're not quite terminal because you're still going fast and slowing down a little bit, but it's about
Mm.
as fast as this slow down as this thing will let you go. If you keep waiting, you're very in just another 60 seconds, you'll hit the Mars at a very high
So
rate of
what do
speed.
we do next? What do we do on this second
So,
stage
so
of
the
trying to
next
slow
step,
this machine down?
that, right? So the next step is exactly what you do if you were an astronaut coming in. This is the Apollo spacecraft bringing the astronauts back from the moon, Neil Armstrong. It would look something like this. The next slide, if you bring up the next picture next to it, there's a the next thing you can do is you open a parachute. Now,
Right?
on Earth, that parachute, uh, could be you could wait till you're below the speed of sound, and that's what the vehicle, which exactly what they did in the Apollo days. But we don't have we can't afford to wait. The ground is coming up so quickly, so we open up a parachute at 2 times the speed of sound. Now, speed of sound on Mars is slightly slower than Earth, but not much slower. So it's still going screaming fast. We open this parachute at 1,000 miles an hour, and it slows us down in this thin Martian atmosphere to about 200 miles an hour.
So it's still 200 miles an hour.
You're still
Okay.
going 200 miles. So with this huge parachute, big parachute, you're falling through the thick atmosphere, through the thin Mars atmosphere, at the same speed as a skydiver without a parachute is going down. In fact, a little bit faster.
Yeah.
Skydiver would watch this thing go past them. So, and as you know, but you've already pulled your parachute out. Now what do you do? Well, now you're out of parachutes. You have to do something else. So this is where we're at the point where now we're below the speed of sound. Now we can use rockets, just like the Apollo astronauts, and convert this thing into a lander. So if you go to the next slide, this is
So we jettison the heat shield, we jettison the parachute,
right.
and we're left with this.
You're
So
left
what
with
are we looking at here,
you're
Rob?
looking at a very much like the lunar lander with the Apollo astronauts. There's
Yeah.
this one has a few more extra rockets. The Apollo astronauts had one big rocket. This has 8 smaller rockets that are firing downward on either side of the rover. So it's really a rover with its own jetpack. And so its job is to slow the vehicle down and to make sure it's going straight down, no horizontal velocity, but straight down, gradually slowing down to something like half a meter per second.
Wow.
Very, very slow.
Rob, I'm just going to give viewers, new viewers who have come in and maybe a little bit late, just a recap of where we are, because I'm going to ask you about the next phase, which looks so amazing. I'm so excited about the next bit. We're also going to be showing you some live images of Mars. We've got some fantastic video actually that we took last night. But you are here with SLU Community Observatory. I'm Paul Cox. I am joined tonight by Rob Manning from the Jet Propulsion Laboratory, and he's telling us all about how you land one of these huge spacecraft on Mars and all of the problems associated with that. We've also got some live images like this one. This is live from our Canary Islands Observatory. SLU members get to control these telescopes. And if you fancy controlling those same telescopes, not only can you just join up SLU anyway, but you also, if you join up today, you will get a free pair of binoculars. And I'll tell you, these are not small binoculars. We're going to tell you all about these in our lunar eclipse show. They are a stunning pair of binoculars. So that's a real limited time offer today, Tuesday only. So please, if you fancy joining a worldwide community of astronomy nuts who love controlling the telescopes, looking at not just Mars and Jupiter and Saturn planets, but nebulae and galaxies and all sorts of other stuff, go along to slu.com, click on the membership button, and you'll see all of the details of that special offer. Now, Rob, coming back to you, we have used the atmosphere of Mars to slow us down with our heat shield. We have opened a large parachute to slow us down even more, but we're still not. What
That's
happens next?
Well, that's right. The next now we've done it differently. Each case we need a rocket to slow us down. Now, in
Yep.
the case of this big rover, Curiosity rover, we couldn't use solid rockets and airbags like we did to land Pathfinder and Spirit and Opportunity. Instead, there's airbag technology. Although we loved airbag technology, it just wasn't scalable up to a 900 kilogram vehicle. So we
Now,
had to come
Rob,
up
sorry
with a new
to
trick.
interrupt. I think I saw this tested, didn't I? Because you guys at NASA have got this enormous vacuum chamber. And didn't I see a test where you had one of the spacecraft kind of covered in these enormous kind of airbags and
That's right.
you were dropping it in that vacuum? Is that what I was seeing?
That's exactly what you were seeing. We were
Wow.
dropping both for Pathfinder, Spirit, and Opportunity. We tested the airbag designs in the world's largest vacuum chamber in Sandusky, Ohio, 20 foot tall, 80-foot wide vacuum chamber. We built a big rock platform of wood and steel and bolted big rocks to it and dropped it at about uh, 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 70 kilometers per hour, 40 to 50 miles an hour, um, on these rocks to see whether these airbags would behave. And
You
so,
do know you have the coolest job in the world, don't you, Rob?
oh, it is. It's absolutely nuts. And so, and especially when you're, climbing over these rock platforms and saying, "Oh my gosh, am I going to convince myself that these things are really going to work without tearing to shreds?" In fact, they tore to shreds. We had to redesign those airbags over and over again. And to be honest with you, those airbags started driving us crazy. And so we really came to the conclusion we had to come up with something new and totally different. And the one logical approach is put a lander underneath your rover and land your rover on top of a legged lander, like we did, like the Viking or the Apollo landers.
Yes. Yeah.
Except that one of the troubles with that is that the rovers are so heavy. Their top makes the lander top heavy. It's very challenging to find landing sites that where the engines would clear the rocks, and that you can, and even then your rover hasn't landed yet. You're still a meter or two above the ground. So we said, let's turn this upside down. Let's put the lander on the roof of the rover, and that's what we did. And we said, well, but how do we get it down? Well, the way we got it down is the way helicopter pilots, sky crane helicopter pilots, Sikorsky helicopter pilots have been doing for years, lowering payloads to the ground with a control system up on top, and cables that literally lower the vehicle down. And then as it gets closer to the ground, the whole helicopter, this jet powered helicopter, lowers it right onto its wheels.
Rob,
No
when I
land.
first saw this, I saw this before you guys were actually going to deploy it. And I have to say, I thought you guys were nuts. It looks so science fiction to me. I mean, this image that we're looking on now, and just the thought that this spacecraft is having to do this autonomously. You can't control it because, as you said earlier, it takes too long for the radio signals to get from Earth to Mars to start controlling it. So it has to do all of this on
Yes,
its own.
yes, 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 and yes. It's funny. People were telling us we were nuts when we were trying to bounce a vehicle as high as a 14-story building on Mars. And I have to admit, it was nuts. But we somehow managed to get it to work. But we had to come up with something equally nuts to get something this big on Mars. And this
Yeah.
was our trick that we came with, literally, actually 14 years ago, long ago when we first thought this up, and and uh, uh, and it seems to have done the job. It turns out controlling a system on a pendulum worked pretty darn well.
And this is
Um,
the size of a saloon car, isn't it? That's what you're dangling from these wires.
yeah, yeah, it's just you could a Mini Cooper,
Yeah, I mean,
basically.
yeah,
Yeah,
it's absolutely astonishing
it's pretty
when we
impressive.
start thinking of that technology. So, I started that whole question off by asking you, well, okay, Rob, you kind of got quickly involved with this EDL, this entry, descent, and landing problem, and I was asking you, so what's so challenging about that? Well, I think you've given us a fantastic description
Thank
of
you.
how and why and what you actually succeeded in doing. I mean, the sense of achievement when you actually receive the first messages back, which confirm that your spacecraft has actually got landed on another planet, on the red planet safely, must be, I mean, almost overwhelming.
I think sense of achievement. But more in this particular case, it was a sense of intense relief. This turned out to be a very expensive mission, and
Yeah.
unlike Spirit and Opportunity, I remember Spirit and Opportunity landed. I had two chances. Spirit landed first, and I had 3 weeks, almost to the minute, between landings, and that gave me enough time. If anything went wrong with the first landing, I could. There are things I could do to figure out how to fix it or the problem, maybe change the software even. Uh, but on this mission, there was only one vehicle, and all of our eggs when this are in this one six-legged, six-wheeled vehicle. And it put a lot of pressure to make sure this was right.
Well,
And
I'm going to ask you in a minute for an update on Spirit and Opportunity, because I know that you were involved with those. But just to remind viewers, you are here with Slough Community Observatory. I'm Paul Cox. I'm joined tonight by Robert Manning from the Jet Propulsion Laboratory. We are seeing some live images of Mars tonight, and our producer is going to show us a couple of the color images that we grabbed last night. Don't forget, we're running a promotion tonight. You can join Slough and you get a fantastic pair of binoculars, which we are going to talk about in far more length. Not so much for the promotion, but actually tell you later on in the eclipse show, the lunar eclipse show, how to use binoculars to view things like the moon, and you can see Jupiter's moons and stuff like that. But with this promotion that we're running tonight, you get the free binoculars with the Slough membership. With Slough membership, you get to control Slough's robotic telescopes from the comfort of your own home. It's really easy to do. We have a fantastic community around that you can join in. So even if you're an absolute newbie, we all remember what it was like, how daunting this subject can be. And I'll tell you, it's a great deal of fun, as well as very rewarding when you build up your own collection of fantastic astronomy photographs. And maybe you might get into one of our science campaigns, like searching and monitoring near-Earth asteroids. But back to tonight, Mars is closer to Earth than it has been in 6 years. And what we've been doing tonight is having a look with Robert Manning from JPL about the missions that have gone to study our nearest neighbor. It is probably the world, the planet, which has inspired more fiction than any other. It's an amazing planet which we've been fascinated by for, well, since we've known it was there. And Rob, you were involved. It's 10 years. I think it was just this January gone was 10 years of roving on Mars with Spirit and Opportunity. Now, those rovers, they weren't meant to last 10 years, were they?
no, we designed them for 90 Mars days, which is a little over, it's about 100 Earth days.
I didn't
Uh,
realize that.
and so it was a bit of a shock. We didn't think we could make it through with solar powered vehicle through a cold Martian winter. Mars, of course, is very cold.
Yeah.
The air is very, very thin, only 1% of Earth's carbon dioxide. It gets even at in the warmest part of times of days on Mars in the summer at the equator, it warms up to room temperature. But even your nose is 40 degrees below zero, just a few feet above the ground. It's a cold, cold place. In the wintertime, it's much colder, and the sun gets dimmer, and dust rains down from the sky itself, covering your solar panels. So there's no way that we thought that these vehicles would be able to survive a cold winter. Yet what we found that Mars provided a something that we didn't count on. It didn't happen with Spirit, with Pathfinder and Sojourner. What we found is that occasionally, just occasionally, the Mars would provide wind gusts, sustained winds that would sandblast the dust right off our solar panels.
This is one of the questions that we had from a viewer coming in. By the way, I forgot to tell everybody, you can ask questions tonight for Mars or the lunar eclipse later. Just use the hashtag SLOOH. That's SLOOH. And that was exactly one of the questions we had. Somebody said, look, these things are solar powered. Surely I have to clean my solar panels at home. Surely they get covered. So Mars is kind of doing a self-cleaning job for you up there.
It is, and we were not expecting that. Now, it turns out it doesn't happen very often. In the case of Spirit got further away from the orientation, which allowed it to get more sunlight. It collected more and more dust. It stopped, its solar panels stopped getting clean. And one day, we had some failures of our front wheel, we lost Spirit. Spirit died a few years back. We struggled over a course of a year to try to get contact with it again. Never did. We think what happened is it actually froze. And
Oh.
so, yeah, and so
So this is 2010, isn't it, that Spirit stopped?
that's about right. Yeah, about
But it
2010.
still has these fantastic statistics that
Oh, yeah.
it traveled nearly 5 miles across the surface of Mars, and it took something like 100,000 images. Now, just by
Yeah.
coincidence, 10 years anniversary of Spirit and Opportunity, but it's also SLU's 10th anniversary as well. And up at this robotic observatory, which you know about, Rob,
Yeah.
the environment isn't quite as harsh as Mars, but we do get these extreme ice storms. It's high altitude, so we do get quite a few problems. And I look after the observatories. I'm the observatory engineer. And I must say, it gives me a greater appreciation knowing what I have to do there to keep the equipment in tip top condition, to suddenly realize what you guys are doing, and you're doing it with this distance, with what, 50, 60,000 miles away. But the other factoid that I've got is Opportunity is still going. Now, that has done something like 24 miles. It's traveled 24 miles, which I must say over 10 years is it's not a very high average speed, but I think you've explained why. And Opportunity has given you guys 187,000 images back from Mars, which is absolutely amazing. SLU members, when I said that to them a little bit earlier, they reminded me that over the 10 years of SLU, now I'm not being competitive in any way, Rob, but SLU members reminded me that over SLU's 10-year history, they have taken 3 million. In fact, we think it's probably over 3 million images taken with the SLU robotic telescopes over that period of time. But it's an
That's
absolutely
fantastic.
to comprehend that you guys are doing this on another world
Yes.
is what gives us our fun and enjoyment about watching the work that people like you do. So there we are. That's where we are today. But you're also, aren't you, working on the next generation? And this is where I'm fascinated to hear. It's kind of your new job title. It's the Low Density Supersonic Decelerator Project Chief Engineer. Now, listen, you guys love these kind of little things, don't you? LDSD. What, Rob, is low density supersonic deceleration, and what are you going to do with it?
Well, what we've discovered with the technology, the technology of a heat shield, a supersonic parachute, and rockets at the bottom, that could get us a long ways, a lot of stuff to Mars. It's something, a 900-kilogram rover we got on Mars. However, if you want to land something that was twice as heavy or even heavier, you need to come up with some new tricks. We need new tricks up our sleeve in order to land that much stuff on Mars. And so we need new ways to slow down. The heat shields just weren't big enough. We couldn't make them any bigger because the launch vehicle fairing is only so wide.
Oh, of
Uh,
course, you're restricted. This is restricted by when you say the launch vehicle, you mean the rocket that's going to take this thing away from Earth, yes?
That's right. The
Yeah.
rocket that launches off Earth has a rocket fairing that protect it on the way up. And you can only make those so big because then the rocket can't doesn't have enough lift capability to lift you in the first place.
Yeah.
So what we found, what we just needed is some other way to increase the amount of drag area of our vehicle so we could use more of that very thin atmosphere of Mars to
Okay.
slow us down faster and higher up so that we can slow down before we hit the ground. And so we've come up with we built a vehicle, and this vehicle is a vehicle to test new ways to slow down at Mars. Now, we're not going to do this test at Mars. It's much cheaper to do it here on Earth. And so what we're doing is we're going to take a vehicle that's here in Pasadena right now. In a couple of days, it will be put in a C-17 cargo transport aircraft and
Mhm.
flown to Hawaii, where we will take it up on a high-altitude balloon and test these new decelerator technologies. Well, what are they?
Wow.
Well, take a look at this other image. Let's just cue it up here. Perfect timing. What you have here is imagine the heat shield is up in this picture, and that white part is the heat shield, and the back part is where the parachute would normally live.
Okay. So it's kind
Surrounded,
of upside down from its normal orientation, yes?
it is indeed, and
Okay.
what you see around in yellow is an inflatable decelerator. It's a donut that inflates in a fraction of a second.
Ah, so you're
Imagine.
totally increasing the surface area of this thing.
Exactly right. And we inflate that with gas generators, going about 4 times the speed of sound. And we'll do that at about 150,000 feet above the Pacific Ocean, just west of the island of Kauai in Hawaii. And we're going to be doing that this summer in just in fact, in just a few weeks, June 3rd is our first attempt to try this, launching this on the balloon. A big Star 48 rocket, solid rocket motor, will eject it from this. When it falls from the balloon, it will fly, spin its way up, and actually get very much higher than the highest balloons that we can get this vehicle as high as possible with this very high altitude balloon. And then from there, this test of this decelerator will happen. But that's not all, because we're also going to test the deployment of a new supersonic, larger parachute that is larger and different architecture than the parachutes that we've used for landing all of our other Mars missions since the Viking missions in the 1970s. So we
What's
will.
enabling you to take those kind of steps then, Rob? Is it some kind of fluid dynamics or computing power? What is it that's enabling you to design things like new supersonic parachutes?
Well, certainly computer simulations go a long ways, but ultimately, the only way to really convince yourself that these systems work is to test them in relevant environments. And going at those speeds, at these altitudes on Earth, we can get this test vehicle into a Mars-like condition and really prove to ourselves that these technologies will work. And in fact, that's how we use the parachute in the first place. These kinds of tests were done over Roswell, New Mexico, back in the early 1970s. And
Wow,
so,
don't worry about the background noise at the moment. We'll try and work through that, Rob.
okay, so those technologies were invented and tested back then, and we've been using them ever since, and since the early 1970s, using the very same technologies. But finally, we've been able to get ourselves to take the next step and to try out even larger and better technologies, just coming up this summer. And with
So,
luck, we'll be able to use these in new Mars missions.
so Rob, what new missions are coming up? Are there things slated that is going to use this, or are you developing the technology before the actual missions are then designed?
A little of both. We've got missions that are look. We have a new rover that's being developed for 2020 that may use some of these technologies. We're still working on that, but definitely for missions that need to, for example, Mars sample return mission. That is something we'd really like to do, is to go to Mars and bring back a handful, literally a handful of Martian cores taken from core samples from rocks and bring them back to Earth. But to do that, we need to launch a launch vehicle. The launch vehicle from the surface of Mars weighs a lot, and it has to be carried to the surface somehow. And in order to slow it down, so we can launch it off of Mars with the sample, we need new ways to slow down just for that.
Okay. Well, thank you for that. Excuse us viewers. We've got a few sound problems here. We were trying to get Bob Berman to join the show, but we will answer some of your Mars questions
Yes,
in the next
and
show.
I'm here. I'm Bob Berman. I'm here.
Bob, if carry on talking, because we had a bit of a mucky audio from you there. So let's test it off and see whether or not we can get you in the show.
Okay. Well, this is Bob here. I've just been connected into SLU just now for the first time in the last minute. And we're here at Prescott Observatory. It's just turning into nightfall, and Mars is rising.
Bob, you got some really strange audio. I think what we'll do is we'll try and get you back in a couple of minutes' time, if that's okay.
Oh, that would be fine. Thank you. We'll
Okay.
do a little troubleshooting from this end.
Okay, thank you. We have got some questions lined up for Mr. Bob Berman, talking about why Mars is closer to Earth than it has been in 6 years. And I can tell you now, just a little brief thing about that. It's about the eccentricity of Mars's orbit. In fact, Rob, you can probably help explain that, because isn't part of that orbit eccentricity, and when we say that, we talk about how circular it is, or not, as the case may be, because doesn't that affect when you can launch a new mission to Mars?
That eccentricity is, yes, part of it, but just the fact that Mars is orbits about once every 2 years around the sun, and Earth
Yeah.
goes around obviously once every year. And in order for them to line up, so that when we launch our vehicle, remember, think about this: when we launch our vehicle from Earth, we put it in orbit around the sun. And if any orbits around the sun have to be in the shape of an ellipse. And that means that the farther part of the ellipse should be at the orbit of where Mars ought to be. The trick is launching out of Earth such that when our vehicle gets around the other side of the sun, on the far side of that ellipse, Mars will happen to be there when we arrive. In fact, most people don't realize that when we arrive at Mars, we don't aim for Mars. We aim for a point where Mars will be. And in fact, Mars comes in and slams into the back of our vehicle from behind.
I love it. I love that description. You wait for Mars to slam into your vehicle. So
it does.
I hope you guys got some good insurance.
Well, we do. Parachutes.
Listen,
heat shields.
Rob, what else can you tell us about the upcoming missions and some of the work that you've got? What have we really got to look forward to in the next kind of 20 years? Is there some big thinking going on at NASA? Are we ever going to see human beings step foot on Mars, or are we always going to be looking at these fantastic machines that you develop and engineer?
That's a great question. We obviously have a lot up our sleeve in the near term. For example, we're still hoping to get MSL Curiosity rover to the base of Mount Sharp in the coming year, where we hope to see some really fascinating new layers of the base of Mount Sharp, where we hope organic molecules might be stored in the layers of clay we can see from the distance. Now, that's near term, but we also have the next for robotics missions, the next big step for us is to, as I mentioned before, to bring back a sample from Mars. So what we've got on the docket right now is another vehicle that's based very much on the MSL Curiosity design, except this rover will collect core samples of Mars rock, collect them all up so that later on another mission can come along, grab them, and fly them back to Earth.
Oh, so it's two-stage collection missions. That's an interesting one. You guys are really thinking out of the box. I mean, I know that's what you guys kind of do, but it's still, I find all of that fascinating. Listen, we have got Mr. Bob Berman coming back into the show. I just want to remind viewers where you are right now. You are with SLU, the Community Observatory. We operate some robotic observatories which anybody can join up and control the telescopes. This wonderful image, by the way, that we're seeing at the moment of Mars, that was taken by SLU partner Matt Francis at the Prescott Observatory in Arizona. And Matt is going to be providing our live lunar eclipse images in our show in a couple of hours' time, in our lunar eclipse show. But I would like to, I must tell you, don't forget, we're running this special promotion today. If you join SLU to join the rest of the SLU members around the globe controlling those telescopes, you will receive a free pair of binoculars, and they are fantastic. Just go along to slu.com, press the membership button for full details of that promotion. You will not be sorry. But I would love to introduce now Mr. Bob Berman, who is SLU's astronomer. Hello, Bob. Can you hear us now?
I hear you perfectly well. How do you hear me here at
Yep, that's a lot better. Now, hopefully, you've been hearing this fascinating discussion that we've been having with Rob Manning from JPL tonight. I know that you will have a bunch of questions that you'll want to ask him, but could you please, Bob, as SLU's astronomer, explain or answer the question that we had? Why is Mars closer to Earth tonight than it has been in the last 6 years?
Well, the Martian orbit is very eccentric. It's not as round as the Earth orbit. So if you picture one circle, like a bullseye, inside an outer circle that's not round, you know that the places where the two circles meet or are closest to each other vary. So when Earth catches up to Mars, we travel at 18.5 miles a second. Mars only moves 15 miles a second. So we're faster, and we will catch up to Mars every 2 years and 2 months. But we can meet Mars at a narrow gap in our orbit. We did that on August 28, 2003, the narrowest gap in 50,000 years. Or we could meet at the widest possible gap, and that's what happened the last opposition in 2012. This one is close to as bad as it gets, but it still is closer than we've seen Mars in the last 4 years and 4 months.
So that also then explains the other question that we've had in. And by the way, you can ask questions tonight for either Mars or the lunar eclipse later on, just using the hashtag SLOOH, that's SLOOH. So send us any questions you've got there. But Bob, that also explains this second question then. And that's why Mars can appear very different apparent sizes through a telescope. And I think 2003 was the last time that we really saw it looking nice and big, but it's not looking so big at the moment, is it? And Matt's
No.
with you, I know, and I know, Matt, I think you'll agree that it's pretty difficult to image well at the moment, isn't it?
It's a challenge because it's only 15 arc seconds. One arc second is the size of a $quarter coin at a distance of 4 miles. So this is a tiny, tiny thing. 15 arc seconds means all of the detail is much smaller than that, 1 arc second or less. And so you need a lot of magnification to see anything on Mars, and more magnification enhances the blurriness that's always attendant with our atmosphere. So the larger Mars is, the better. It was 25 arc seconds back in 2003, and then it'll get to 24 arc seconds a number of years from now.
So
Unfortunately,
you said 2018 is when it's again at its biggest and brightest, yes?
yes, it won't be as big as 2003, but it'll be pretty darn big. Unfortunately, at those times, it tends to be lower in the sky than it is now. It's nice and high, and that's pretty much over the celestial equator, over Earth's equator. And
Okay, well,
that's some compensation at least.
thank you for that, Bob. Now, you be thinking about questions that you would like to ask Rob Manning from JPL, talking about all of the fantastic engineering projects that he's been involved with, getting spacecraft and landers and rovers onto Mars. We have got Jonathan Thorne has messaged us, and he's asking, will we be on air all night virtually? We are going to round up the Mars show in about 10 minutes time, but we are going to be back in about 2.5 hours. We're going to start the lunar eclipse show a little bit early. So if you see all of the advertised times, let me get the time here for you. The advertised time is 11 p.m. PDT. That's 2 a.m. EDT. Now, if you'd like to join us maybe half an hour early, we're going to start the show half an hour early, and we're going to have a little bit of banter while we get ready for that lunar eclipse show. So make sure you come back, because a lot of people are clouded out tonight in the USA and in South America and in Canada. So the place to see it is going to be the live images coming direct from Matt Francis's Prescott Observatory, and we're going to talk more about that observatory a little bit later. So, Bob, questions for Rob. Rob, I hope you're still there.
I am.
You are. Bob, what would you like to ask Rob?
Well, Rob, I'm going to, of course, Mars has all the juice, the energy, the electricity. This is the War of the Worlds, the H.G. Wells, the Howard Koch radio script that Orson Welles read, the scares, the aliens from Mars, all the movies. Of course, Mars has all the juice, and we keep going back almost every time Mars and Earth meet. My question for you is, what do you say, how do you answer the naysayers who say that now that we've sent ever more sophisticated devices to Mars, have not found life yet, should we not turn our attention to, let's say, the moons of Jupiter, such as Europa, with its warm saltwater oceans, and put more of our marbles in the bag of looking elsewhere? How would you answer those people?
Rob, are you still there?
I think I floored him, Paul, with that question. I think that was just too much. That was
Bob,
too long a question.
What have you done? Anyway, while we try and get Rob back into the broadcast, we've got another question here, and it's a fascinating one that hopefully we'll get Rob back onto the show. Callum Byrne has asked. The first part sounds like conspiracy theory, but it's not when you read the rest of his questioning. He says, how do NASA know so much about Mars despite never being there? And how did they know about the conditions when they sent the first rover?
Well, of course, we did not know the conditions. The first instruments, landers, really were the Vikings back in 1976.
But we had orbiters before then, didn't we, Bob?
And we had orbiters before, so it's a gradual process of accretion, of getting more and more knowledge and information, and we started with very little. We did not even know that Mars had craters back when I studied this stuff in college. And so it's an ever-increasing process of learning about Mars. So the only way you're going to do that is sending the best stuff there.
I couldn't agree more. What's so great about Mars is that we can do the kind of detailed, long-lasting exploration. Someday, I want to do the same thing on Europa and Enceladus. There's the possibility for life in our solar system is real. If not extant life, and certainly evidence for past life is not impossible. And I want us to find it because I believe it's there. We've found the more we look, the more we find that we've just confirmed that Mars was indeed a habitable place for life 3.5 billion years ago. It was a place that if Earth organisms had been there, they would have thrived in those conditions. So my view is, why not? We also know that life can transport across the solar system. My view, it's almost inconceivable that life, perhaps even Earth life, has made voyages across between the planets, and I believe that we will find signs, signatures of past life on other places in our solar system.
I agree, Rob, and I think the other thing, the other aspect of this, which makes it seem more and more likely, is our greater understanding now, and it's advancing every single year, of the kind of harsh environments on Earth where life can actually exist, whether or not that's the heart of a nuclear reactor or the depths of the ocean. We're understanding more and more how adaptable life really can be. So I don't know. The odds have got to be for it, but it's a fascinating debate to kind of say where the money should be spent. And frankly, there's not enough money to go around to be exploring everywhere that we should.
I agree. I really wish in my lifetime that exploration of these outer planets, the icy moons, will happen. Because I really do think there's a lot of exciting things to do there. I have to say, though, they are hard places to go. I've worked on some of those missions, and it is difficult to send a vehicle to land and explore those kind of places. It is not like going to Mars or Earth's moon. It's another thing altogether, and particularly around Jupiter with the radiation environment.
Radiation, that's the problem there.
It's a huge problem. I'm very excited about this recent results from Enceladus, where a southern ocean has been confirmed, and possibly Enceladus, which might be a little bit easier to get to than even Europa. But someday we will go, and it's really all about resources. But I'm really crossing my fingers that will happen in my life.
Rob, it's about resources, but it's also, I think, what you've shown us tonight, our viewers tonight, is a greater appreciation for the kind of engineering genius and creativity that it's taken just to even get us to the red planet, which is what we've been watching tonight. We're looking at an image here, which Matt Francis from the Prescott Observatory took last night. We had some live images coming in from Sloo's Canary Islands Observatory earlier on. Mars is closer to Earth tonight than it has been for 6 years. And we've heard from Rob Manning, from JPL, how they've done this incredible exploration and engineering projects to actually land and explore there. We've heard that Opportunity, the rover that was designed to only last for 90 Mars days, is still going strong after 10 years. I mean, that has to be some engineering prowess there. I mean, really, my hat's off to you. So, Bob, have you got any other questions for Rob before we start winding up the show?
Well, of course, I wonder, Rob, what you felt about a few years ago when Dan Golden and the team at JPL stood there and announced that ALH 84001, I know you know that Antarctic meteorite like the back of your hand, announced that they had discovered life, at least fossilized signs of life on Mars. And the result of that, I mean, of course, now we know that that wasn't true, that it was a false or a mistaken announcement. But surely you noticed that at the office water cooler the next morning and throughout, there were not people saying, "Did you hear that? They found life on Mars." And so when we say that it'll be a game changer, that everybody will be so excited if we find life of any kind, I wonder what your thoughts are if we only find bacteria, moss, that kind of thing, and it's not kittens or scary octopus-looking things. Do you really think the public will be excited about something that's abstract on another world? Or is it just you and me who will be excited in the home?
It might be just you and me, but I don't think so. I think I listen, think about life. I was thrilled with that announcement. And by the way, I'm still a big fan of ALH 84001, not because it found life, but it gave us, it changed our way of imagining what might be possible. That life might be transportable from planet to planet is now taken seriously as a scientific proposition. So, I really think that if we just find evidence of, think about this, if we find a bacterial-like life forms on Mars, and in fact, if we could bring them back to Earth and actually analyze the DNA structure, and we were able to find that these DNA were fundamentally different, say, for example, had a left-handed chirality, it would be revolutionary. It said that life can form in different places. Let's just say it's just like Earth, and it may have even come from Earth, or more interestingly, maybe life started even before on Mars, before it even started on Earth.
In which case, we're all Martians.
In this case, we're all Martians. Exactly right. What it says that there is almost an inevitability about life in the right conditions over billions of years. Life could happen, and not just here in our little solar system, but other places as well. And to me, I think life goes with our universe, and I'm excited to be part of it.
Absolutely. I'm with all of you all the way. We have got 2 questions before we round up this part of the show, but don't forget, we have got our live lunar eclipse coverage. We are going to be with you for the whole eclipse with a fantastic lineup of expert guests to guide you through it. And one of our questions here is, if people want to see Bob, this is a question for you. If people want to see Mars tonight, where do they find it? I think the answer is going to be, it's going to be pretty easy to find because it's very close to the moon that's going to be eclipsed tonight. Is that right?
That's right. Well, the closest object to the moon will be the star Spica, the blue star Spica, that will be just under the moon. But to the right of the moon, can't miss it, in the same color. I've noticed some media, by the way, are calling this a blood red moon. No, it's going to be more like a coppery or orange. If you ever find that your blood, you have a cut and your blood is orange, then you should get some lab questions. But an object pretty much the same color as the fully eclipsed moon will be just to the right of the moon. And yeah, that's Mars.
And that's Mars. And you won't see anything unless you've got a fairly decent telescope. But if you haven't got a fairly decent telescope, then I recommend joining SLU, and you can control our own robotic telescopes from the comfort of your own home. And if you join up with the rest of the legion of the astronomy community who are using the SLU telescopes, you will get a free pair of binoculars. But we are going to round up this part of the show. You have to join us later on for the live lunar eclipse, even if you are under clear skies in North or South America where it's visible. Then keep us on, because we're going to guide you through every single phase of that eclipse. We're going to tell you exactly how you can look at it, what's happening, what Timothy, author of Seeing in the Dark. We've got filmmaker and documentary producer Duncan Kopp, plus Bob's going to be joining us again. We're going to hear from Matt Francis at the Prescott Observatory, where Bob is, plus some other guests as well. Rob, it goes without saying, thank you very, very much for joining us tonight here on SLU. You've given us a wealth of information, and I'm sure you've inspired a new generation of space engineers who maybe will be designing the spacecraft that go off to those moons that you were talking about a little while ago. So have you got any last words for our viewers?
No, I just want to thank you for inviting me, and I really hope that some people who are smarter than me can figure out how we can discover life on the moons of Titan and Europa and Enceladus. I will be a big fan.
Me too. And like you, I kind of wish to myself, I hope this happens in my lifetime. I'm really, really want that kind of discovery push to go on. Rob, actually, somebody has just asked us, do you have a Twitter account that they can follow your work or maybe your department's work at all?
I'm afraid I don't. However, our Curiosity rover does tweet. So if you look
Okay.
for Curiosity rover, you'll be able to keep track of what Curiosity is doing every day as she works her way toward slowly but surely to the base of Mount Sharp. In fact, we'll be starting up a new drilling campaign on a new set of rocks here in the Kimberley area in the next few weeks. So you'll see some action from Mars here coming up real soon.
Well, I have to say that
it was a girl. I knew it was a girl. You confirmed it.
if that's what you're doing, Rob, we will
Yeah.
definitely get you back in a few weeks' time to hear more about what you find there. Bob, have you got any more words for viewers in our Mars show, or
No.
have you got anything to kind of get people whetting their appetites for the lunar eclipse a little bit later on?
I can't wait. It's a very, very exciting. It's coming really soon. We have covers of guest coverage, and wow, strange things are about to happen in the sky with Mars. It's closest to Earth in years, right next to the eclipse moon. When have we seen that before? The answer is never. So very exciting. The night's just beginning.
Absolutely. And if you couldn't catch Bob's audio quite there, we have got a hell of an exciting show later on to watch the whole of the lunar eclipse, total lunar eclipse, live here on the SLU Community Observatory later on. That is 11 p.m. PDT, 2 a.m. EDT. That is 0600 UTC. But maybe join the broadcast a little bit early, join the SLU homepage a little bit early, because we might be starting that show maybe about half an hour early, just to have a quick banter, maybe discuss some of the things that we've been talking about tonight before we start the show proper at those times. Thank you very much to my guest, Robert Manning from JPL, NASA's Jet Propulsion Laboratory this evening. Thank you, Mr. Bob Berman, for joining us. Thank you, Mr. Matt Francis from the Prescott Observatory, showing us these fantastic images of Mars, which he took last night, those ones. Thank you very much to our producer, Michael Wilson in the United States. We are going to be back with you in a couple of hours' time, 3 hours' time, I think it is. Join us here at the SLU Community Observatory. I'm Paul Cox. We'll see you a bit later for the lunar eclipse. Don't miss it. See you then. Best live shows we could do. First of all, we've got Mars. Mars is closest to Earth tonight than it has been for 6 years. And then, in a few hours' time, we are going to have live coverage of the total lunar eclipse. Now, I know that a lot of people in the USA and South America, where you can actually see this in your own backyards, I know there's a lot of cloud over there. So we will be providing you with live images so you can watch it all the way from beginning to end. Now, not only have we got those two events lined up, but we also have a fantastic promotion tonight. Join Slew to control those robotic telescopes alongside all of the other members, and you will receive a fabulous pair of free binoculars. They're worth $90. They are a really, really nice set. These are not cheap binoculars. They are fantastic. I have actually got my hands on a pair now. It's a limited offer today. We make no apology for running a promotion or telling you about Slew during our live shows, because it's what keeps us going. So please go along to the slew.com homepage, click the membership button for details, and we'll tell you more actually about how to use a pair of binoculars a little bit later on in the show. Now, we've got our first live image of Mars. This one's a bit fuzzy in comparison to some of the ones we've been seeing earlier tonight, but we can just about start making out some of the feet in space and astronomy.
Well, great question, because I was definitely inspired by the space race.
Me too.
I was the perfect age to witness the dawn of the whole thing. In the early 1960s, Alan Shepard and the other astronauts, Gus Grissom, a whole slew of the astronauts,
Yeah.
suddenly filled my vocabulary, my brain, and I was watching first the Mercury missions and the Gemini, and then the Apollo, and as a kid, you just followed it like it was a daytime drama. Every moment you could get your hands on a piece of paper or a magazine that explained something, because we didn't have the internet, of course, and
No.
so I was far from TV, so I had to get all of my information from newspapers and magazines, and so I scoured the paper to find out what was going on, and it was just such an exciting time. But gradually, we were able to watch black and white television shots of amazing things, such as Neil Armstrong's first steps on the moon. I will never forget that. July.
I remember, Rob, being woken up by my mother, brought downstairs to watch the black and white TV, to watch that very instant. And it was features on Mars. And we'll talk about that in the second part of our show. The first part is we've got Rob Manning. Mr. Robert Manning. He is the MSL chief engineer, or former MSL, that's the Mars Science Laboratory chief engineer, and is now heading up an amazing project that he's going to talk to us about. But he's also going to give us a fantastic update about Curiosity. Sorry, which ones? No, we got Opportunity and Spirit. Sorry, I got a bit confused there. The 2 rovers on Mars. Anyway, Rob is going to give us an update on that. Then later on in the show, we are going to be joined by SLU astronomer Bob Berman, and he's going to explain why tonight is so special and why this is the first time in 6 years that Earth and Mars have been this close. He'll also explain why Mars is closest tonight, even though the planet's opposition was last week. Some people are a bit confused by that, so we're going to clear that up. And then in 3.5 hours' time, we are going to have the second of our big live events tonight, the total lunar eclipse. It is going to be an awesome show. We will be broadcasting live image streams of the eclipse so anyone can enjoy this gradual darkening of the moon, and hopefully we'll see the moon turn red or orange as it's plunged into Earth's shadow. Now, if you're lucky enough to live in North or South America and you have clear skies, be sure to listen to our commentary as you watch the eclipse from your own backyard. But for those of us, I'm talking to you from England, for those of us under the clouds or located where the eclipse isn't visible, we'll have those live images throughout the eclipse. So make sure you come back later for the live eclipse show too. Now, if you're watching in your own backyard, make sure that you join us in our little pre-show. So we're going to start a little bit earlier for the lunar eclipse, and we're going to tell you exactly how to watch it in your own backyard. But before our live eclipse coverage starting in a few hours' time, let's get back to Mars, our neighboring planet that has captured the imaginations of kids like me, novelists, filmmakers, and scientists alike. And to help bring us up to speed on the current Mars exploration missions and what's planned in the future as well, I am delighted to welcome Rob Manning from NASA's Jet Propulsion Laboratory back to SLU. Good evening, Rob. Many thanks for popping back to update us on your exciting work on the Red Planet.
Good evening, Paul. Thank you so much for inviting me. It's a great pleasure to talk to you again.
Well, we were talking with a group of SLU members the other night amongst all of us, and we were saying, what was it that first inspired you to kind of get interested in astronomy and space? And one of them said, ask your guests on Monday night. Ask your guests. So, Rob, what inspired you to get interested? Hello, and welcome to SLU, the Community Observatory. I'm Paul Cox, and I look after SLU's robotic telescopes, and they're the telescopes that our worldwide community of members control every night. Now, our primary observatory, you're seeing it here, is at the world-class observatory site in the Canary Islands, which is off the west coast of Africa. It's home to some of the biggest and best telescopes in the world. But shortly, SLU are going to be reopening their Chile observatory, which means that SLU members will suddenly get to control the telescopes in the southern hemisphere as well. Anyway, you are joining us tonight for 2 of the biggest and